Today let's look at what is actually AI, machine learning and deep language at a very broad perspective from a very high level. So what is ML or machine learning? ML is a subset of AI, and if you consider AI as a discipline like physics, then probably ML is like uh, a subset of it. Like in physics, you can consider atomic physics as a subset of it. So that's how you need to think AI and ML. So machine learning algorithms can learn from data and improve their performance over time without being told what to do. That's what is machine learning. So now under machine learning, you have something called unsupervised ML models and supervised ML models. Your supervised models are used for prediction, whereas your unsupervised are used for classifications. Your supervised learning models, right, are generally used like your spam filters, your fraud detection systems, your recommendation engines, your image recognition systems use supervised learning models. So generally, when you train a supervised learning model, you give a data and a label to that. So the other advantage of supervised learning models is that it generally remembers, formulates, and predicts the output. Your unsupervised learning models are nothing but it does a classification. So you have unlabeled data that you pass to the ML and train it. So say that you train the data with only dog, then you pass a cat image, then it tells that it does not fall under this group, but it definitely tells that it is not belongs to this group. So that's what it generally does. Generally, your unsupervised learning models are used for customer segregation, generally segregations, or anomaly detections. For those, they use it. So let's now see how actually unsupervised or supervised learning models in a flow. So the supervised learning models, right? They take a input data, then you have a model, and the model predicts an output, and that output is compared with the training data set with an expected output. And if your expected output is a less loss, then that means your predicted output is the actual output that you have got. And if your loss is actually large, that means your model is not predicting the output what you expected. And so one thing is you need to update your model or change your model in way that or you need to train your model with the proper data. Whereas your unsupervised learning model is like pass an input, the model takes the input and generates an example or an output, or it classifies the data. So now let's look at what is deep learning. Deep learning is actually a more complex. It's a subset of machine learning that uses artificial neural networks to mimic the learning process of a human brain. So under machine learnings, you have supervised learning, unsupervised learning, reinforcement learning, and deep learning, because deep learning is again a subset of machine learning. Neural networks can be both, can take both labeled and unlabeled data, which is called as semi-supervised learning. So if you see in semi-supervised learning, a neural network is trained on a small amount of data, labeled for small amount of data, labeled data, and a large amount of unlabeled data. That's called semi-supervised learning. So normally a lot of unlabeled data would be passed to a neural network. So but what is a neuron? Neuron is nothing but this is the structure of the neuron would look like. So it takes an input. For each input there is a weightage which you multiply, and then you do a summation of all these input that comes to that particular neuron, and then you add a bias. Then there is a nonlinear activation function. So these nonlinear activation function, there are a lot of nonlinear, like hyperbolic, sigmoid. There are a couple of them. You can have a look if you go to TensorFlow and just type in Google, just type non-linear activation function for TensorFlow or PyTorch, you may get all those functions. So to activate a neuron, if the output is 0, then it is not activated. If the output is beyond the threshold, that is greater than 1, then it gets activated. So what is a generative AI? Generative AI is nothing but a subset of deep learning. Generative AI is a subset of deep learning, which means that it uses artificial neural networks and can process both labeled and unlabeled data using supervised and unsupervised and semi-supervised. So now, large language model is also a subset of deep learning. So that's how all your ChatGPT, BERT, all these fall under large language model, which is actually a subset of your deep learning models. So deep learning models generally take your supervised, unsupervised, and semi-supervised. Semi-supervised, as I told, it takes labeled and unlabeled data, where unlabeled data is actually large. So what do they do? So what do large language models do is that they have two types of techniques. One is your discriminative technique and generative technique. Discriminative technique is nothing but it does a classification of the data. Say you pass a dog, then it tells whether it's a dog or not. That's what it does. Whereas a generative technique, you pass a dog, then it generates a new image or it generates a new content out of that. That is called generative technique. So now so these models, right, they have this model of these models. How do they look like? So the traditional model is you have data and labeling of the data, then you pass it to the model, it predicts the output, and it gives you what type of data or what type of prediction it can do. Whereas a generative model, it's an unstructured data where you pass it and it generates a new content using the unstructured data. So now let's look at what is a generative AI and what is not a generative AI. Say that you have a model Y, which you have Y is your output, where F is actually a model and X is your input. So you have function. So when Y is a number, discrete or probability, then it is not a generative AI. When Y is a natural language or an image or an audio, which is actually be generated. So let me give an example. Like if Y is a number, it is like predicted sale. It is not a generative AI. If Y is a sentence like define sales or define something, or it can be anything in the natural language, then it is a generative AI. So large language models, right, or the generative AI models are supervised, as I told, it's semi-supervised and unsupervised learning. So you pass in, you have a foundation model which has been trained across with different data sets like labeled data, unlabeled data, and training codes. Then it could generate new content out of that. So one thing is that generative language models, right, before this say that you want to actually tell a program to based on the input to tell whether it's a cat. In your traditional programming, you would tell that cat is like this, it has 2 ears, eyes, and cat is like a fluffy, and that's how you do. Then we moved on, and then you label the data, and then you started giving the input, and then it starts predicting it. Then we started moving on to the generative AI. So now you give a corpus of data to it, and it takes that entire corpus of data and it processes it, and later the model is ready. Then you tell, can you define a cat? Then it's simply using that knowledge that it has got trained, it starts generating the definition of a cat. So we have come a long way from a classical programming to a generative AI model where it can learn and give you an output. So generative AIs are generally based on different types. Different types, like it can take an image and it can output text. It can take input as image and output as image itself. It can take image and it can output videos. So you have I think now you have different um, tools outside which you can actually use a single photo and create a video out of it. Then you have text, where it can output text. Then it can output images. Based on that, it can do decision. Then it can output as audios also. So how do you actually train generative AI? Is like so the architecture generally is like this. So you have a transformer where you have encoder component and a recorder component. Then you have the generative pre-trained transformer model, which you use it. So you pass the input with a lot of labeled, unlabeled, and unstructured data to it, and you train the model. So normally your GPTs or do not use encoder architecture. They use only the decoder architecture, whereas your BERT, which is used by Google search engine, uses encoder format. So as these fields are getting popularized, and the prompt engineering or the prompt design would be very new field and new job market altogether because of these deep learning and generative AIs. And any generative AI should have a prompt. You need to prompt the system to interact with you. So prompting is nothing but you can just tell it to summarize a book, you can tell it to write a poem, so you can tell it to create a Spring Boot application and give it all its method information, properties, and it will generate for you. So normally you tell it to summarize, it summarizes it. Tell you to write a poem, it writes. You tell it to write code, it writes for you. So now let's look at the three kinds of LLM models. They are generic language models, and then you have instruction tuned models and dialogue based models. So generally your generic language models that predicts the next word is based on the language that it got trained. That is what it does normally. Let's look at instruction based, trained to predict the response of the instruction given to it. So during the prompt you tell I want to write a code, so it on a Spring Boot, then it writes a code. So based on an instruction it acts. So dialogue is like more of a chatbot. That's what I tell, trained to have a dialogue by predicting your next response. So the two main fields that would get emerged is your prompt design and prompt engineering. Prompt involves instruction and context passed to a language model to adhere to the desired task, whereas prompt engineering is a practice of developing and optimizing the prompt for effectively use language models for a variety of applications. So you develop a model and then you build a prompt. You build an ecosystem around that model to give you an output. So the next big thing is the foundation models. Foundation models are nothing but these models are trained with huge amount of data with different type, like text, image, speech, structured data, unstructured data, 3D signals, and these things. And these models can be adopted to variety of use cases like object recognition, image capturing, instruction following, adoption, sentiment analysis, and all. So foundation models would really revolutionize the industries in the healthcare, finance, customer care services, basically your development, your productivity tools. So it would be part of each and every field in the coming years. So that would really revolutionize the entire industry and the landscape because of these new large language models using the foundation model. Yeah, this is what is all about this new buzz around what is people called as AI or ML or deep learning, it does not matter. So this is how it is. This is a very high level. Yeah, catch you in the next video. Bye.